Hi, I'm CubicLies. Welcome to my first video series about command blocks in vanilla Minecraft. Vanilla modifications are all about manipulating data in the world using the commands which are part of the game itself. This first series is not about all the things you can do with commands. It's more about how to make command blocks do what you want, when you want it. I will be talking about activating chains of blocks, timing the execution of chains, using conditional blocks in simple and complex cases, and finally, I will cover clocking and scheduling of chains. If you're just now coming to command block coding, the good news is that it's easier and more powerful than ever before. These tutorials are for Minecraft 1.9 and above. This series assumes you already know a bit about command block programming, but I will quickly review the parts relevant to what I will be explaining. I suggest you download the world file containing these examples to examine at your own pace. The official Minecraft wiki is a great reference for the commands themselves. A command block in Minecraft contains a single command, and that command is executed when the block is activated. Complex programs and modifications to gameplay can be created with a number of command blocks working together. There are now three types of command blocks. The impulse block replaces the old standard command block and will continue to work in old-style constructions with redstone, comparators, and fill clocks. Impulse blocks perform their single command a single time when activated. Repeating blocks are the second new type. These blocks will activate once per game tick, or 20 times per second. Here are a single impulse block and a repeating command block. When I activate these, you can see their single command executes either once or repeatedly. New style command blocks have a facing direction, which is indicated by the block texture, and determines the flow of execution and conditional tests when the blocks are chained together. When an impulse block or repeating block is activated, a chain of blocks depending on it will be activated in order, following the flow of execution. These blocks are the third new type of command block, the chain command block. Chains can be quite long, and all of the command blocks in the chain get a chance to execute during a single tick. Here are examples of chains of blocks. This one depends on an impulse block, and all of the blocks execute once per activation. This chain here is using a repeating block, and it activates 20 times per second, as long as the repeater block is active. All three command block types have conditional versions, which execute their command only if the block behind them was successful the last time it was executed. The blocks can also be turned on or turned off using block data rather than redstone, which avoids chunk updates altogether. Activating chains to run a single time is best done by heading the chain with an impulse block, which you turn on or activate by using the block data command to set the auto value to 1. This corresponds to the always active toggle in the interface. As you can see, an impulse block will execute its command each time the block is edited to turn on the always active option. This block here activates chain number 1 here on the bottom. As you can see, the impulse block which initiates chain number 1 promptly turns itself back off. This prepares the chain to be activated again. You can use this technique to make looping chains which reactivate their own impulse block at the end of the chain. A chain of blocks flowing from a repeater or impulse block will execute reliably within a single tick. But if you activate one chain from another, that chain will begin in the following tick. This is illustrated in this example here. As you can see, we have 3 chains, each depending on an impulse block for activation. Chain number 1 activates chain number 2. Chain number 2 activates chain number 3. When I activate chain number 1, you can see 3 messages appear announcing the beginning and end of each chain. These messages are actually preceded by a scoreboard value for the clock 1 value objective. Here is the tellroll command I'm using for these debug messages. This repeater block here will increment the clock 1 value objective once every tick, or 20 times per second. Now when I activate chain number 1, you can see that each activation occurs 1 tick later. If you have a need for operations to occur within a specific number of ticks for timing or synchronization, you'll need to keep this in mind. Also notice that the chains complete their execution during the tick in which they were activated. The block data command effect does take place immediately. However, the impulse block will not be scheduled for execution until the following tick. So the location of the block data command within the chain doesn't really matter. Here in chain number 1, it's at the end. But in chain number 2, it precedes the chain end message. The activated chain does not execute until the following tick. Some things to remember from this segment. Impulse blocks and their dependent chains execute once per activation. Repeating blocks and their chains will execute 20 times per second while active. You can use block data to activate blocks rather than redstone, which avoids chunk updates. A chain activated from another chain will execute in the following tick. And finally, a global tick counter is useful for debugging issues with timing and synchronization. Another quirk of command blocks is the logical flow of conditional blocks versus the flow of execution. The execution flows through a chain in the facing direction of the blocks, indicated by the arrows in the block texture. A chain of blocks can turn a corner, and execution will flow through the turn. However, conditional blocks are not fed their condition by the block that precedes them in the flow of execution. Instead, they read their condition from the block behind them, based on the facing direction. This means that a block cannot be conditional upon a block through a corner. While this effect is occasionally useful, most of the time it is an annoyance. Also, if a block is conditional, only that block is affected by the conditional test. Whether or not the conditional block executes, the rest of the chain will execute. You can see this illustrated here. On the left, we have a chain in which the repeater block is testing for a player in close proximity. There is a conditional chain block which will display a green particle effect when a player is nearby. The next chain block displays a red particle effect as long as the chain is active. As you can see, the green particles appear when I approach the blocks, and the red particles display continually. To the right, we have the same chain repeated, but with a 90-degree turn at the conditional block. When I activate the chain, you can see that execution flows through the corner as the red particle effect is visible. However, the conditional block is not activated. This conditional block is actually checking the repeating block behind it. This repeating block is not facing into the conditional block at all. It's facing the opposite direction and feeding another chain. There are, in fact, two conditional blocks reading this repeating block. This block is performing a check for a nearby item rather than a player. When I activate this second chain and drop an item, you can see that both green particle effects will appear. It's also interesting to note that when I deactivate the second chain and then pick up the item, the first conditional block here continues to display its particle effect. This is because the condition of the repeating block persists even though it is not executing. Avoiding conditional tests at corners will affect your building when you cannot simply extend your blocks in a straight line. Some things to remember from this segment. Conditional blocks read the block behind themselves, not necessarily the block that precedes them in the flow of execution. The execution of the chain continues after the conditional block, regardless of the result. Conditionals can be annoying in a corner. Blocks can be conditional on blocks from other chains. And finally, blocks retain their condition even when inactive. With the conditional versions of command blocks, only the block itself is activated or not, depending on the condition. The rest of the chain executes regardless. Therefore, if you need to use the condition more than once, you will need to add additional testing and conditional blocks. It is not always as simple as chaining multiple conditional blocks together to execute multiple commands on a true condition, because each block is testing the previous block rather than the original test. Only if there is no chance of failure of the commands can you get away with chaining conditional blocks. You must repeat tests if you have multiple commands to execute depending on the condition. Also, there is no built-in negative conditional block, so if you want to perform an action when a condition is not met, additional tests are required. Here we have an example which tests the location above the emerald block to the left. If a diamond block is found, this block here is set to diamond block, and a message is displayed. This example uses chained conditional blocks. So the second block, which displays the message, depends on the success of the first block, which sets the diamond block. As you can see, if the diamond block already exists, the set block command will fail, and therefore the message does not display. To avoid this, you must test the result of the original test to determine whether the second command should execute. This is done using test for block to see if the success count was 1, indicating true. In this example, you can see that the second dependent command, which displays the message, is conditional on the test for block command checking the original test. This example works whether the diamond block exists in the indicator location or not. Some things to remember from this segment. You must repeat tests if you have multiple commands dependent on a condition, and there is any chance of commands failing to execute. The test for block command can be used to test the result of a previous test, true or false. And as there is no negative conditional, you must use test for block to determine false. Chain activation, conditional blocks, and testing the result of tests are the building blocks for command block logic. In the next video, I will demonstrate several advanced techniques for building complex tests. Here we have a more complex example of the test of test method. In this case, we're checking for a diamond block above the emerald block here, and if it's found, we present two messages. If it's not found, we check if there's a quartz block, and if that's found, we present two messages. Finally, if neither is found, we present a pair of messages, and the sequence ends with a closing message which executes regardless. As you can see, a number of extra blocks are needed to accomplish this logic. We must not only perform the tests, we must test the test result for each command, which depends on the condition. And we must test for the failure of the previous test to accommodate the logic. Although in this specific example, you could get away without that because the two block types can't occupy the same space. This example does operate within a single tick. Clearly, this method is not very block efficient if you need to execute multiple commands for each condition. And the large number of conditional blocks makes it difficult to build in anything but a straight line. Unless you have a small number of commands you want to depend on the condition, or are using a program to generate your blocks for you, this method can be annoying to implement. Another technique is to test the condition and branch to separate chains, rather than putting the dependent commands in a single chain. This can be very efficient if you have long sequences of blocks dependent upon conditions. Every branch to a separate chain puts you in another tick, however, and you need to keep this in mind for timing and synchronization. Here is an example which performs the same test for diamond or quartz blocks. As you can see, we have our test block, and then conditionally, we activate a separate chain for the commands to execute when that condition is true. This chain will execute on the following tick, but remember that before that happens, the rest of this chain will still execute. We perform the test for false and conditionally activate the chain for the false branch on the next tick, remember, and this chain ends. If a diamond block was found, this chain here will execute on the following tick. It presents two messages, then activates the break branch in which execution continues. If a diamond block was found, the other chains for testing quartz blocks or failure to recognize either block are never executed. The branches for testing for quartz and the final alternative of no block recognized operate in the same way. Ultimately, the break branch is executed, and the chain of chains program continues. As you can see, the break branch will execute 2 or 3 ticks after the first chain, depending on how many branches occurred. This technique is easier to build than the test of tests method. It uses fewer conditional blocks, and breaking it up into separate chains gives more flexibility for fitting into a specific volume. If you have long sequences of commands, placing them into separate chains can be quite block efficient. In this example, I've isolated the conditional checks completely into separate chains, But if you don't care about the false condition, say you want to check for many different block types and run a different chain for each, this technique is quite useful. This technique is a strange one, as it is a chain which modifies itself as it executes. I hesitate to use this method when I can avoid it, because to be honest, it feels like a hack, and I would not be surprised if the behavior it depends on changes in the future. This method does operate in one tick and does not depend on the scoreboard or entities, but it does cause chunk updates due to the use of cloning. Nevertheless, there are useful applications of the technique and it deserves illustration. When this chain executes, all of the condition testing is performed first, and then the appropriate commands execute. When a condition is met, the commands which depend on it are cloned into place ahead in the chain. When execution flow reaches the replacement segment, the correct blocks should be in place for the conditions. See here are the three different segments for replacement. Notice that there are already blocks present where the replacement segment will be placed. This is important. The chain must exist before the blocks are replaced. The blocks in the chain are scheduled for execution when the chain is begun, so the blocks in the replacement segment will execute if present. The cloning operations replace the blocks before execution occurs. As this method depends on quirky behavior, you might want to avoid its use, but it can be block efficient for long sequences, and it operates in a single tick, but it causes chunk updates. And remember that the blocks must already exist in the replacement segment, otherwise they will not be scheduled for execution when the chain begins. Finally, we have what is probably my favorite method for dealing with conditionals. This method depends on the scoreboard, an entity, execute, and command stats. But once you understand these, it is much easier to build complex command block logic. This method can be combined with the branching technique as well. Here again we have an example of diamond and quartz block discrimination. There are some prerequisites for this technique to work. We have this gentleman here, reg1. He is the entity we will use to receive the conditional test results, and he will perform the conditional actions via execute. We have two conditional tests, one for diamond and one for quartz, so we need two scoreboard objectives. I've named these if1 and if2. The entity must already have a score in each of these objectives, as the stats blocks will not apply the score if it is not already present. So I've already established these objectives and initiated reg1 with the scores. The first two blocks in the chain here perform the tests. We use the stats command to set these blocks to update the if1 or if2 scores on reg1. Once these two blocks have executed, we can use the results repeatedly without having to test the test. And we can act directly for a true or false condition. And furthermore, we could combine conditions into single commands. To use these booleans, we wrap the command in an execute, using a selector to limit the execution to the conditions we need. The diamond block found messages are only displayed if reg1 has a score of 1 for if1. The rest of the chain continues, using selectors to control the execution of each command. Notice that all of these blocks are executed, regardless of the results of the tests. This means that each of these execute commands and the selector must be processed. You must balance the cost of using the scoreboard, entities, and selectors versus the cost of the other methods. I feel that the ease of use of this method usually justifies the computational cost. Furthermore, you may already have a need for an entity for relative reference or another function, so you can simply use the entity for this purpose as well. The stats, entity, and execute method is easy to build, and it can be very block efficient, and there's no issue with traversing corners. You can combine conditional tests into single commands using selectors, and you can use this technique easily with the branching as well. Since it uses entities, the scoreboard, and selectors, you should be careful and optimize for performance. You can use these techniques for conditional testing and execution to create very complex programs with command blocks. Understanding chain activation, the progression of ticks as your commands execute, conditional testing, and the use of the scoreboard and selectors is key to advanced vanilla modifications. In the next video, I will be talking about clocking and scheduling work globally for large projects.